Amphibious cars? The amphibious car exists at the intersection of two things that have no business being combined. A road car is designed for traction, steering, and speed on a prepared surface. A boat is designed for buoyancy, propulsion, and stability on water. Every amphibious car in history has compromised on both sides of that equation, producing something that is neither the best car it could be, nor the best boat, but capable of doing both when the situation demands it. The Amphar, marketed between 1961 and 1968, is the most successful civilian amphibious car ever produced. 3,178 were sold, making it the only civilian amphibious car ever manufactured in meaningful numbers. It reached 70 mph on land and 7 knots on water, figures that made it simultaneously the world's fastest boat and the world's slowest car. Modern amphibious cars like the Gibbs Aquitata have pushed water speeds above 50 km/h using jet drive systems, while the watercar Panther holds the record for the fastest amphibious car ever built at 90 km/h on water. None of them have solved the fundamental engineering tension that every amphibious car faces. They have simply found better ways to manage it. Amphibious all-terrain vehicle. The Amphibious ATV occupies the most practical end of the amphibious vehicle spectrum. A machine built not for impressive speeds or military operations, but for the simple work of getting somewhere that nothing else can reach. Swamps, bogs, snowfields, shallow rivers, tidal flats. The environments that amphibious ATVs are built for are defined by the absence of any usable surface. The Argo, built in Canada since 1967, is the most widely used amphibious ATV in the world. An 8-wheeled vehicle that moves through water by spinning its wheels against the surface, generating propulsive force to cross rivers and lakes without any dedicated propulsion system. The Sherp, built in Russia for Siberian terrain, uses enormous low-pressure tires that deform around obstacles and rotate against the water surface like paddle wheels, generating thrust without any mechanical propulsion beyond the wheel drive itself. Both vehicles prioritize one thing above all others: the ability to keep moving when every other vehicle has stopped. Screw-propelled vehicles. The screw-propelled vehicle is the most unusual amphibious machine ever put into practical use. Rather than wheels or tracks, it moves on two large rotating helical drums, cylinders with a continuous spiral ridge wrapped around their outer surface, like the thread of a bolt scaled up to the size of a barrel. When those drums rotate, the spiral threads engage with the ground, snow, mud, or water beneath them and generate forward motion through a mechanism that is neither rolling nor paddling. The Soviet Zeal 2906, built to recover cosmonauts who landed in the remote Siberian wilderness, represents the most sophisticated implementation. A vehicle capable of moving across waterlogged terrain, deep snow, and swamp that no wheeled or tracked vehicle could cross. The screw mechanism generates thrust by literally threading itself through the surface, which makes it uniquely effective in the loosest terrain on Earth and uniquely damaging to firm surfaces. Screw vehicles cannot operate on pavement without destroying both the surface and themselves. Amphibious trucks. The DUKW, known universally as the Duck, is the vehicle that proved amphibious cargo transport could work at military scale. Built on a General Motors truck chassis with a watertight hull and a propeller driven by the same engine that powered the rear axle, the DUKW carried troops, ammunition, and equipment from ships directly to beaches without transferring cargo at the W's edge. Over 21,000 were built between 1942 and 1945. First seeing combat at the invasion of Sicily in July 1943, going on to operate at Normandy, Anzio, Ioima, and across the Pacific. Modern amphibious trucks have refined the concept. Better waterproofing, more powerful propulsion, higher payload capacity, but the fundamental proposition remains the same as the DUKW introduced it in 1943. A truck that drives into water, crosses it under its own power, and drives out the other side without anyone having to transfer its cargo. Amphibious buses. The amphibious bus serves a purpose that sits between military utility and tourist novelty. In flood-prone cities and river-crossing communities, amphibious buses provide genuine transport infrastructure, moving passengers across water obstacles that conventional buses cannot negotiate. In tourist destinations across Europe, Asia, and North America, the Duck Tour has become a staple of urban sightseeing. A road bus that drives into a river or harbor, narrates the waterfront from the water's surface, and drives back out to continue its journey on land. In the Philippines, the Sarao Jeep has been adapted into amphibious configurations for flood operations in a country where seasonal flooding regularly cuts road access to entire communities. The amphibious bus is the least glamorous vehicle on this list and the one most likely to be genuinely useful to the largest number of ordinary people in the specific circumstances where nothing else serves them. Amphibious Armored Personnel Carriers. The Amphibious Armored Personnel Carrier solves the most dangerous problem in military amphibious operations: how to deliver infantry from ships to beaches while protecting them from fire across open water. The AAV-7 used by the United States Marine Corps launches from the well deck of an amphibious assault ship, crosses open water at approximately 13 km/h, and drives directly onto the beach with troops inside protected by armor capable of stopping small arms fire throughout the crossing. The M113, one of the most produced armored vehicles in history, achieved amphibious capability through a simpler mechanism. Its aluminum hull was buoyant enough to float, and it used its tracks rotating in the water to propel itself across rivers at low speed. Both vehicles share the same design philosophy. The armor that protects troops on the battlefield should also protect them during the most vulnerable phase of an amphibious assault. Amphibious Infantry Fighting Vehicles. The Amphibious Infantry Fighting Vehicle takes the armored personnel carrier's capability and adds the ability to fight. Not just to transport troops to a fight, but to engage the enemy during the crossing and immediately upon landing. The BMP-3, operated by the Russian military and numerous export customers, swims across rivers using water jets, carries 7 infantry soldiers, and simultaneously engages targets with a 100mm gun, a 30mm autoc cannon, and anti-tank guided missiles while afloat. The distinction between an APC and an IFV matters in the water as much as on land. An APC delivers troops to a fight while an IFV joins the fight itself, providing fire support during the crossing that suppresses defenders on the far bank. The South Korean K-21, the Chinese ZBD-05, and the American Amphibious Combat Vehicle represent the current generation of amphibious IFVs designed for the contested coastal environments where future amphibious operations are expected to occur. Amphibious tanks. The amphibious tank is the most paradoxical vehicle on this list. Armor and firepower are heavy. Buoyancy requires lightness. And reconciling those two facts has produced some of the most unusual vehicles ever to enter military service. The Soviet PT-76, introduced in 1952 and still in service with dozens of militaries worldwide, swims using water jets, sacrificing heavy armor for the ability to cross rivers and coastal waters independently without bridging equipment or landing craft. It proved its value in conflicts from Vietnam to the Indo-Pakistani wars, operating in terrain that heavier tanks could not enter. The D.D. Sherman tanks used at Normandy used flotation screens, large canvas skirts that raised the vehicle's freeboard and allowed it to float, swimming ashore with screens raised and engaging beach defenses the moment they grounded in conditions that sank many of them before they reached the shore. Amphibious Landing Vehicles. The amphibious landing vehicle is the machine that makes large-scale opposed amphibious assaults possible. The LCVP landing craft vehicle personnel known as the Higgins boat is the most historically significant landing vehicle ever built. General Dwight Eisenhower credited its designer Andrew Higgins of New Orleans as the man who won the war, stating that if Higgins had not designed and built the LCVP, the Allies could never have landed over an open beach, and the whole strategy of the war would have been different. Over 23,000 were built, each carrying 36 combat-equipped soldiers operating on every major amphibious front from Sicily to Normandy to the Pacific. The modern LCAC landing craft air cushion represents the current generation, a military hovercraft that carries main battle tanks at 74 km/h directly onto beaches, accessing 70% of the world's coastline that conventional landing craft cannot reach. The gap between the Higgins boat and the LCIC spans 80 years of amphibious warfare development compressed into a single category of machine. Amphibious hovercraft. The hovercraft is the amphibious vehicle that operates on a principle none of the others use. It does not float, does not drive, and does not swim. It rides on a cushion of pressurized air contained by a flexible rubber skirt, touching neither the water surface nor the ground beneath it, moving across both with equal indifference to what lies below. The SRNN-4, the largest commercial hovercraft ever built, carried 254 passengers and 30 cars across the English Channel at 83 knots for 32 years before the Channel Tunnel made it economically unviable.